Hello and welcome to part 2 of the series where I show you how to communicate between an ESP32 central and a Pico W peripheral. Last time I showed you basic communication. In this video we will move on to bidirectional communication as we've done in previous series. As usual, I'll show you the setup, the code, and we will run a demo like always. Like last time, I will use the PCBs that were provided to me by PCBWay. And again, thank you very much, PCBWay, for the boards. I will have a GitHub repo for the code in the description below. Let's get started. Alright folks, so let's get started. First, the setup here. The setup is the same as always. We have the Pico and then the ESP32. Now, make sure your ESP32 is set up with MicroPython. I will link the YouTube video in the card above so you know how I did it. And that's all the setup you need to do. You can use a breadboard or you can just have them dangling with the USB cable. Doesn't matter. Anyways, let's get to the code. Now I have it here on GitHub, but I have the code also on the Thonny, which we will run. So the first thing we're going to do is check up Pico perdual.py, which is for the Pico. So first we import the libraries, then we define our LED. We have false for connected. We read the UUIDs file. We set up our Bluetooth peripheral parameters. That includes the BLE name and message and everything else we need. Our message count, our encode and decode functions for the messages, and then of course we have our blink LED task function where we blink the LED as we've done before, and then we have our receive data task where we will read the data, and if there is data we will decode, and of course we will receive from the Pico. This is the send data task function where we have our message count, and then we encode the message this time, and then what we do is we write to it. And remember, peripheral will write data here. Next up, we have our run peripheral mode function. By the way, this connected is connected to the LED that we need to blink, and it's also here as well. Whenever the function ends, we have to set it to false. And then of course we have the Bluetooth service and our characteristic UUID setup. Then of course we have to register the BLE service. Then we advertise using the parameters listed for the advertising interval, the name, the services, the appearance, and then we set up connected to true. Then we have our tasks from before. We gather them, we set connected to false, and then when we're done, we break. And then we run the function here. Remember, that's for the Pico. Now here's for the ESP32. This was ESP32 central dual.py. Just as before, we define our libraries, or well, we import them. Then we read, as we've done before, for our UUIDs. Then we define the LED at pin 2. And then we set up our Bluetooth parameters as we've done with the Pico. We have our message count variable. Encode and decode are still the same. We have our blink LED task as before. We have our receive data task, although this one's different because we read and of course we have to decode the message, but we also have to encode the message since we want to ensure that we got it. Then we do our message count. We have our timeout and exception. And then we have send data task. It's a very small function where we encode, we write, and we delay for a second. And then we have our exception. Then we have our BLE scan, where it will be scanning. So essentially it will set it to 5,000. The interval US is at 30,000. The window is at 30,000 as well. Active is true. Then whatever result is there, we print. And if the name is the same as I am sending to, and the UUID, then it will say it's found and the result name with the UUID. And it will return none if nothing works. Then we have central mode where we scan, and if there's no device, it will continue. And if there is, it will connect to it. And if it times out, we'll set up a timeout error, and it will continue. Then we have our service and characteristics. Then we have our timeout error, as well as our exceptions. We have our tasks. Then, of course, we gather those tasks. And then just like before, we disconnect when necessary, and then we break when we're done. Oh, and then we have to run central mode as well. Make sure to run this function at the end. And that's it for the code. The code's all set up. Now, as before, I have on the ESP32 AIO BLE set up in a separate folder, since it's not included by default. You can install using the tools and manage package option, but I decided not to do that since I was getting errors. On the Pico, everything is all set up, so there's no need to worry. So now let's just get to the demo. Alright, so let's get to the demo. So the first thing we need to do is run the Pico. Oh, sorry, I had to move the boards. So let's run the Pico first. Oh, sorry, I just realized that's the wrong code. It should be Pico per dual. Okay, I had realized this was from the previous video. I apologize for that. So now let's run the correct code. All right, now it's advertising. So we'll run the ESP32 next. And it should run. All right, it's looking for peripheral. And as you can see, we are getting got it, and we're getting the count. Oh, looks like it skipped one, but otherwise it still works. As you can see, it's saying hello from peripheral, and it said got it. Okay, so as you can see, bidirectional communication works perfectly here. So I'm going to stop everything here since we're done. I'm going to stop this, and I'm going to stop this. So everything works as usual. So that's it for the demo. Thanks for watching. Next time we will move on to potentiometer control and finally button control as we've done in the past. See you next time.